Hello, thank you for joining today's webinar sponsored by Index Engines. Today's topic is talking about technology workflow in support of the EU GDPR. Today's session will be about an hour. We have a lot to cover, so we'll probably take about most of the hour. But if you do have questions, feel free to ask them. My name is Jim McGann with Index Engines. I will be your host. I am joined by our presenter, Michelle King, who manages our business development effort for the governance type clients, as well as Ed Moak, who runs our professional services organization. On the right, you'll see a questions option or a questions menu. If you do have questions, type them in. We'll try to get them either during the session, or if we don't have time, we'll follow up afterwards. Okay, so thanks for attending. I'm going to pass it over to Michelle, who will start the presentation.
Thanks so much, Jim, and thanks everyone for joining us. So as we get started today, the biggest concern that we at Index Engines here when we talk to clients about the GDPR is the concern as to the scope of the problem. Frankly, it's petabytes in class, and it's very intimidating at first glance. So our goal today is to show you a proven, repeatable process that'll work over petabytes of data and cut the data set and as such, the problem down to size. So at a high level, as we walk through today's session, we're going to walk through 3 steps. And the first one is to classify, which is to lightly index or profile all of the data under management and to begin to put that data into classifications or buckets so that we can start to dig deeper into it. The next step is what we call search. Search involves a deeper index, a deeper dive into in-scope data that we believe will contain personal information that will be responsive to the GDPR. And then the third step will be to manage the data. Managing the data could be deleting data, could be archiving or copying data, migrating data. There's a lot of different steps here, and it's also going to be about continuing to monitor and protect data, and ultimately, long-term, to manage the data, supporting the DPO with a clear, auditable process to do this. So as we take a look at the first step, we talk about the classification of data assets. When we do this, we often talk about what I refer to as kind of the old school data mapping process of interviewing and understanding data flows and requirements. This is a really important piece of information, and we're not negating it in any way, but ultimately, so is gaining an understanding of the data itself. So we've got 3 buckets here on the screen, and the first one is the one we most typically start with, which is ROT. And ROT is a term that we talk a lot about lately, identifying redundant, obsolete, and trivial data. And we believe this is a really important bucket, not just for deletion, but to eliminate this data from the management process and ultimately to minimize the amount of data being retained and, more importantly, being managed as we go deeper into our process. The next is out-of-scope data. When we talk about out-of-scope, we're talking about out-of-scope from a GDPR perspective. We're not saying that this data doesn't have business value. It likely is very valuable data, but it's likely not to contain personal data. So it's not likely data that we're going to want to continue to dig more deeply into as we walk through the process. And then the third bucket is in-scope data. This is what we're talking about as we dig into the content of data, when we start searching for personal and sensitive information. And as you can see from the premise of the funnel here, it's now a much more manageable size, and it's going to be the focal point as we move forward through the process. So as we talk about the classification process and Ed begins to get into the demonstration, what we've done is we've quickly built an index of the key metadata for all of the data that we're managing. And we're using that index to begin to understand it and ultimately to classify it into the buckets that we're talking about. For online data, that involves a quick crawl of file servers, SharePoint servers, and the like. And while it's not part of what we're going to talk about today, for backup data, it can be as simple as crawling the live backup catalog or touching some backup tapes. On a light metadata pass, we're going to get information such as file names, paths, dates created and accessed and modified, file extensions. And all of this is going to be gathered and made available to the user, as well as additional information from understanding data owners, frequency of access, and even through a deeper understanding of file names. We believe that true classification is an iterative process of leveraging this data, reporting and culling, and then the information that the client can provide, the user can provide, insight into what we're seeing when we're looking at the data. So as we get ready to pass this over and dive into the demonstration portion for a bit, the question that I think everyone's thinking is, why index engines? So I think what you need to understand here is that index engines really is the only application that can crawl both online and offline data sources and can do it at industry-leading speeds. It's the only application that can and has indexed petabytes of data with a footprint at this size, about 1% of the data capacity. Because index engines has done this and can scale out into these petabyte class environments for GDPR. So I'm going to pass the screen over to Ed, and Ed's going to get into the first step of the presentation.
Okay, thanks, Michelle. What I'm going to do is walk through the actual process that you would go through for this for the classification piece of GDPR. The first step is obviously, as Michelle talked about, is to lightly index the data set across your network. This could be petabytes worth of data, to really understand and gather the metadata and index that metadata and make that fully searchable. Next, you're going to use an iterative process of generating reports, working with the data managers and owners to get feedback on the data that exists across the network, and then going and improving results and refine and start that classification process. After the first pass of the indexing pass, you're going to use a standard set of reports, and then you're going to refine those reports as you understand and gather information from those data owners and managers. You can also utilize the reporting capabilities of index engines to utilize additional tools to further refine the results, like word map, like creating cloud word maps, which I'll show you in a little bit. In addition, during this process, you're going to work with those data owners and managers to start to identify where the personal data may exist, and identifying data that's not only redundant data, outdated and trivial, but also data that's in scope, data that you need to keep, data that you need to get off primary storage and into an archive, and we'll show you that process here. The first thing we're going to go to here is our dashboard, and what I've done is created a standard a set of reports on our dashboard. These are customizable reports that the users, you and the users can develop, and they can be automatically updated. In this particular case, I've got a report that's run showing me where my duplicate files are, and being able to show the duplicate count by the owners of the files. Index Engines is integrated with Active Directory and has the capability to search by group, by Active Directory groups, resolving the file identifiers across the network to the actual Active Directory usernames. These are interactive reports. I can hover over and get a bar chart showing the actual owners, how much data they own, how much data is redundant, and the number of files. I've also got a chart for access time greater than 3 years and displaying that by the Active Directory group. Again, these are interactive reports. I can click on an individual report and not only see the distribution across the Active Directory groups, but I can now go and look at that data and where it exists across the file locations, across the shares, across the network. I can look at the data in terms of sizes and find out how big those files are. So again, truly an interactive set of reports. Looking for modification time greater than 3 years and looking at it initially by the extension type. Finding my trivial files, non-business related files across the network, looking at that at a first glance by the file extension, but again, I can go into the actual report, I can go in and see in more detail the amount of data, the number of files, and click through to it to see actually who owns those data as well. Look at the data that's owned by ex-employees. or data that's recently accessed within the last one year, and be able to look at where that data may exist. So the first step is to get an understanding, and using the standard reports to get an understanding for where the data exists, who owns the data, start to put it in bins and getting it ready for classification. The next, I can also create custom reports within my system, and I can look at and create multi-dimensional custom reports utilizing all the various metadata components that we index with that light metadata indexing. So again, I can look at and create a report, maybe by the owner, dragging the owner over to group by the owner, wanting to see the distribution under that owner by path, and looking at it by the size of the files, grouping by size of files, and maybe by the number of files or the count of files, and being able to drag that and create truly a multi-dimensional report. This will produce a CSV that you can take out to any of your data visualization tools or data reporting tools to help understand that data better. Searching data. Searching data is done in many different ways. The most common and easy way is to actually look at the data by the shares that were indexed. So I can look at this particular host that was indexed, look at a share under that host, and be able to now drill down within that specific share, seeing in this particular case, my departmental shares, and seeing the user shares in that particular server. I can select any one of those shares, selecting the operations share, running my search, and then identifying and narrowing down to just the files in the operations folder, looking at the individual files themselves. So being able to actually look at the metadata for that specific file, seeing the created and modified access time of a specific file. I can click through to the file and actually open that file up on my desktop. Being able to open that file, if that's what I want to do, to get a better understanding for that file. I'm not going to go through with that now. I think we've got limited time on this thing, but you can see the application coming up. Or I can go to my reporting capabilities and now start to look at the files within operations, just like I did on my dashboard, looking at by who owns the files, what type of files they are, the extensions of the files, and so forth. Being able to drill down within that specific share. So now that we've indexed at a metadata level, we can now have the capability to actually search and use Boolean operators to search on those metadata fields. So what I can do, I can open up. I've got some saved queries here. Looking at my metadata, I've got a metadata example. In this case, being able to look and find all files that have the salary in the path, or looking for PST files. If you've got a policy that you're not supposed to have rogue PST files out on the network, I can look for those, or look for any other identifiers within the path or the file name using all the standard Boolean operators. I can now run that search, see that I've got, in this case, I've got a number of PSTs that, hey, they weren't supposed to be on my network. I can now go in and look and see, who owns those PSTs. Where are they on my network? Looking at the locations or the hosts, seeing the sizes of the specific files, or going back and actually looking at the individual results of that file. So clearly, going into the interview in the data mapping part of the process, you've clearly got an edge up against the competition, being able to just now search on that specific metadata. Arm yourself with reports to be able to start to build that data map much earlier in the process and have that information. With an understanding, we understand what traditional interview-based data mapping processes look like. This really this additional data will give an impression that is unbelievable to the end customers, being able to be armed with this type of data going into that data mapping. So now that we've worked with our data owners, we've worked with our product, managers of that data, we can now start to classify the data and apply tags to that classification so that we can act on those tags later on in the process. So let's go back to and look at, we've already identified that data access greater than 3 years is data that is older than we need to keep. We can take action on that data, so I can set a query up here, my access time greater than 3 years, and I'm looking at it for the different Active Directory groups. I can now run that search. I can identify and tag all those specific files and give it a tag as outdated. I'm going to take action on that specific tag later on in the process when we talk about managing data. But in this case, I can now start to add tags and assign files into the specific classification bins. One other classification I can make at this point in time, I know my ex-employees data, and there's a large number of files out on my network that are ex-employees. This is data that I may not want it to delete, but I believe that this is in-scope data, but I don't want it on primary storage. So I want to take action on this data later on. I'm going to tag that data as, say, in scope, but I want to archive that data later on. We'll go through that archiving process. So apply that specific tag, and now we've got those files tagged now for action later on. The last thing that I can do here is I have the ability to, we've added a capability into the product. It's not on our GUI yet. It will be within our next GA release. But it's a command line option that allows you to export a word frequency table. So being able to, in this case, we've done a word frequency on the file names, being able to export that CSV and then load it up into an external tool to provide a word cloud.
Thanks, Ed. This is great. This is obviously way more intuitive than just looking at a CSV file. It's been very helpful for a lot of our clients. Okay. So just to recap, everything that we walked through was surrounding the first classification step, assuming that we indexed a large data set on the metadata level and started to get that data classified and organized. As we move forward, we're going to step into the next step, which is that search step, and we're going to start talking a little bit more about content. So as we do that, the first thing I want to touch on a little bit is the GDPR's definition of personal data. And we've all seen it and we've read it probably many, many times. And I don't know about you, but every time I do, I feel like it's such a wide, broad range of data that could be responsive. And it really leaves me thinking. For example, is everything that I'm looking for identifiable? Is it everything located with terms and key items that are going to help me to do that? And how do I find personal data if I don't even really know in some instances what I'm looking for? I know that it could be there, but what is it? And the bottom line, really, as we move into this next step, none of this is cookie cutter, right? It's going to take a tool that has some pretty robust capabilities, and it's going to take a process that utilizes all of them to really get the job done here. So to that, the only way to do this is to take the next step, and it's to deeply content index the data. Now, the good news is that up to this point, we've taken that process and we've culled down our funnel. We're now looking at a smaller subset of data, but could still be pretty large. But we're going to index that data on a deep, full content level. So again, why are we going to do this with index engines? And it really, again, comes down to the fact that index engines is the only product that's going to content index this volume of data at unprecedented speeds. We can support indexing of up to 1 terabyte an hour on a single system with a single job. We can combine multiple jobs and even multiple systems in federation to support indexing, search and query, reporting and archiving in a petabyte class environment. And we're going to do this with about a 5% footprint from a data storage perspective. So as Ed steps into the next section of his demonstration, we're going to assume that we've deeply content indexed this data, and we're going to take a look at some of the search options. So from the index engine's perspective, when you start to build a strategy to identify personal data, it really isn't cut and dry. It's not going to be the same from vertical to vertical or company to company. And based upon the type of personal data you collect, the forms you collect it in, the types of subjects you're collecting it from. So we really need to think about different options to do that. And there are some products that will say that keyword or Boolean searching is going to do this. Others will leave that out completely and push towards pattern or regular expression searching. But the bottom line is, unless you've got a technology that's going to utilize multiple methodologies here and scale them out to a petabyte level, you're not going to be able to comply with the GDPR. So as Ed walks through from the search perspective, he's going to look at all of these. He's going to look a little bit at keyword searching, which, while it's pretty self-explanatory, you'd be surprised how many people omit it in the process. It's something that a right to be forgotten request would work real well with. Pattern searching. Since Index Engines builds a full text index, we can do pattern searches right at indexing time, and that's going to give you a very fast response time when you're searching, but it assumes you know what you're looking for from the beginning. In the event that you don't, or there is a pattern that's maybe not yet in the application, you've got regular expression options that you can search right through that full text index again. And then the last thing that Ed will take a look at from a search perspective is concept searching. We often see personal data discussed in email conversations or otherwise, where a lot of the specific identifiers that we look for aren't present. So concepts, as Ed will explain, will make this an easy piece to conquer.
Thanks, Michelle. So now we're ready to take a walk through the workflow for the second step. We've identified the data that may be in scope. We've performed a full content indexing pass on that data. And now, with knowledge of the searching strategies, of understanding where that personal data may lie, what that personal data may look like, we can then look at the index engine search and reporting capabilities of the product. I'm going to take you through a couple of examples. The first example is a request for personal data for a specific person. For example, a right to be forgotten request from a John Q. Public. We're going to search for John Public across our data for the content in our data, whether it's John Q. Public, just like as it exists here, whether it's John near 10 words of public, or whether it's John Public. We're going to run that specific search across that data. We can see the individual search results. Again, I can click on that and see the reconstruction in the text highlighting the John Q. Public. And sure enough, we've got his date of birth, we've got his social security number, and so forth. But I can look at that data as well, again, using my reporting capabilities. So I can now see who owns the files that have John Q. Public's information in it. I can look at where is that data located, in what folders of that data, and how many files and how much data is actually located there across the locations of the data. And look at it in how often was that data accessed in the last 30 to 90 days or 7 to 30 days and so forth. So again, I can now drill down into that, produce a set of reports and CSVs, and now take action for that specific right to be forgotten request. So if you've got a list of identifiers for personal data, whether it's an email address, an employee number, or a customer account number, you can create a specific Boolean search, keyword search for that data, find all the instances of that personal data, but have the flexibility to be able to identify that data and look at that data, whether I'm looking at it on a specific host or a specific share within that host across the date range. I have that flexibility within my search capability. Okay, so let's take a look at our second example. And we're going to go into pattern searches and talk about pattern searches. So patterns generally can be represented by a regular expression, or they really adapt to an algorithm or a specific form within the data sets. Almost all have embedded codes or algorithms that can distinguish them from just some sort of random number. Index Engines has the ability, has patterns, a number of patterns already built into the engine itself. We capture those patterns and identify those specific patterns at indexing time. So while we're running that full content indexing, we understand where those patterns exist, whether it's a credit card number, whether it's a social security number, whether it's a bank routing number, whether it's an email address, a name, a customer, a business, a location, a street address. Those type of things we capture at indexing time. So let's look at our first example here. We're going to look for where our social security numbers may exist. Now I'm going to do this in what I call a narrow view, because I know across my data set, I've not only got social security numbers, but I know there's specific words around those numbers, the word social or SSN or SS. So I can add those Boolean operators into the search for the keywords around that data and be able to reduce the number of false positives. Run my specific search, and again, I can see the results, the individual files, the results of those searches, being able to, again, go into the text, look at it, and sure enough, that's a social security number. Being able to go over to my report page now, and then start to drill down and find out where that data, oops, I don't have the location set up for that, but who owns that specific data, how old the data is, when the last access time was, where the data exists. I can now have the ability to understand where those files exist, so I can take action on them, tag them and take action on them if that's what I want to do. The second type of pattern searching for things that we don't have. Index Engines is adding new patterns all the time. We're adding many of the government patterns across the EU into the system. But where we don't have a pattern, you can always use the regular expression to identify that specific pattern. In this case, I've got, I know I'm in the EU, and I'm looking for Finnish social security numbers, and there it is. I'm going to bring that search up. I'm looking at that in a specific location, so I've narrowed it down to a specific directory share, and I'm looking for in the body where that regular expression that identifies Finnish social security numbers. I can now run that search, identify that there is one file. It's owned by Mickey Mouse. I can go back to my results page. I can click on that and see the text reconstruction, and sure enough, there are those Finnish social security numbers. So again, just a second type of pattern searching. Many of our customers come to us and ask that they want to add new patterns, and we do that all the time for them, to add the pattern into the system so that it's a much more efficient way to do it at indexing time. The last example is really, so we've talked about keywords, we've talked about patterns, but oftentimes personal data exists across the network that is not that obvious. So in this specific case, I've got email across my data set, and this was a particular email between two doctors talking about a specific person, Paul. May have some identifiers in the documents. It's a discussion about a case that Paul has, it's a malpractice type of email. So these type of personal conversations are not unusual. And GDPR, there's no exceptions in the GDPR for data like this. You have to be able to identify this data across your data set. Clearly, this particular email and this particular data set, it's personal, it's identifiable, but the real problem is, how do I find that? How do I find that specific data? The answer in this particular case is really identifying a concept and identifying concepts within your data set. This is a concept that would be a medical malpractice concept. And the key to finding this is to search for the concepts, not the specific content within the concept. So how do I do that? Index Engines has added to its capability a conceptual engine. It's built on machine learning, something that e-discovery has been used for a long time, used in the legal coding process. They called it predictive coding. we use it in the conceptual engine to be able to identify concepts within the product. So how does that work? You break down your data, identify the distinct concepts, and then use that conceptual engine and the process that Index Engines brings to be able to train the conceptual engine to recognize the concept. The concept engine will then generate a weighted set of terms for each concept that you want to identify. And then you can run that weighted set of terms across the petabytes worth of data across your network. We've done that here for this specific example. We've trained the engine. We've got a weighted set of terms. I'm going to bring that up now. I've loaded those terms into my search. So here I'm looking through the body. I'm looking for and here's our weighted set of terms. And this is a fairly lengthy set of a weighted set of terms that I'm going to run across my search, run across my data set. Run that specific search. Takes a little longer. It's got a lot of terms in it, and really there's no limit to the amount of terms that you can run. I can now sort on my screen. I can sort that data by relevance. See that data set in order of relevance. And now I can, once this returns, I can go in and look at that data, as specific data, look at the content, the text of that data, and see the highlighted terms that were in my query. Again, I still have the capability now to go and run reports to now identify where that data exists, just like I could all the other searches. Being able to identify the owners of that data, where that data exists, how old that data is, so I can take action on that data. Okay, looking back to you, Michelle.
Great, thanks so much, Ed. All right, so as Ed walked through essentially the search section, we talked about different types of searching, different ways to identify personal information under the scope of GDPR. As we move forward, which I was trying to get ahead of myself and do a little bit earlier, we're going to move into the final section, the manage section. And as we do this, I want to briefly talk about defensible disposition. Typically, the minute I say disposition, people immediately think deletion, but disposition is way more than that. If you think about it, the act of disposition is really about putting something where it belongs. And there are several places you might want to put data that could be part of a successful GDPR strategy. So when you think about the GDPR, it delivers citizens the right to access, rectify, erase, restrict, or migrate personal information, and it defines a lot of key timeframes and requirements in this process. So deletion is part of it, yes. It could be that throughout this process we've uncovered rot and we want to delete it. It could be that we've identified personal information that needs to be purged in accordance with the GDPR. Migration and archiving are also components. Might be out-of-scope data that we identify that no longer needs to sit on expensive storage. It might be in-scope data that needs to be protected or moved to a new location for anonymization. All of this is possible right within Index Engines. We can delete, we can copy, we can archive data right from within the tool. In fact, the archive that comes with Index Engines stores data in a highly compressed, deduplicated format, but it keeps the index alive so that the data is searchable and compliant. Plus, we can store that data either locally or on inexpensive media, maybe out in the cloud, EMC's ECS or Amazon's AWS or Glacier. As you'll see in a moment with Ed, since the data's already been indexed, this process is going to be really, really easy. Finally, monitoring data, managing and protecting that data. That's all about automating the process, and that's all steps in a long-term GDPR solution, as is defensibility. Whether it's copying, deleting, migrating, or archiving files, or even extracting data to produce for a data subject, reporting an audit trail is going to ensure that every step in the process is defensible and support the DPO throughout. So Ed's going to take a look at these actions within the technology, and he's also going to take a look at some of the data security features. The last thing that I'll talk about before I flip back is about protecting personal data. The GDPR is pretty strict in mandating notifications and fines for breaches. You know, it seems pretty clear to us that deleting data that isn't necessary, or archiving data that can be archived are two very logical approaches as a first step. But for data that needs to be maintained, it's all about monitoring that data to ensure that it's safe.
Okay, thanks, Michelle. I want to take you through this last session. We're going to talk about managing your data, whether it's in scope or out of scope data, and taking action on some of the classifications we did earlier, as well as looking at how to protect and monitor the data access and permissions. First, I'm going to go through my first example. We're going to go look at that data that we marked as out of scope, and we're going to take action on that data. So I've got remember we tagged that data in the first section. I'm going to go here and I'm going to search on those tags. Again, I can now search by the tag of outdated. Look at that data. Make sure that these are in fact the files that we tagged before, which in fact they are. We're going to select that data, and now we can take action on that data. First thing we want to do here is we want to actually delete this data from source. We've determined that this data is outdated. It's not needed on primary storage anymore, and we can free up that primary storage and start to get a return on our investment. So delete the data from source, and before we can delete the data, we have to pick a validation mode. So at deletion time, we actually validate that each file either has the same modification time as that we've accessed, the indexing time, or the document signature and size. So it's a simple verification to make sure that the data hasn't changed, it's not been recently accessed, and it's still the outdated data, and then we can actually submit that job for deletion. Not real interesting to see that. I've already got a job that I've done before. If we go over here to my jobs page, we can go down and look at a deletion job I did in a demo last week, a deletion job. I deleted 100 files, about 27 megabytes. But more importantly about deletion is making sure that we've got an audit trail for defensibility of that job. And sure enough, we've got a CSV here that we can download. I'm going to open that CSV real quick to show you the important components of that defensibility trail. First thing we see is the actual file. So the requested file name, the full path, including the file name, so we know what files were deleted. And there's some metadata fields here. All the metadata fields for that file are included in the report. But more importantly, who actually ran the deletion job. So the username that deleted the job. This happens to be an admin user. Index Engine supports multiple users in the system that can be added, and each user can have a different role with different permissions. So Index Engine supports user roles and permission based. So we know who deleted the job, and we know at what time the deletion job took place. So again, we know what file was deleted, who deleted it, and when that file was actually deleted. A full defensible audit trail for that particular deletion. All right, let's go to our second example now. We're going to go back here to our search, and we're going to look at that data, the ex-employee data. We determined that that data was in fact not needed on primary storage, but was not data that we wanted to delete. We determined that was in-scope data, and we want to remove that from local storage, from primary storage, which is extremely expensive, and move that to a cloud-based archive, where it will still be maintained and be searchable using the Index Engine's appliance. So again, I'm going to go and search my tags here. We've got our in-scope archive data. I can select that tag and search on that tag, verify the data is in fact my archive data. Now I can go down and either select all the files for those ex-employees, but for now I'm just going to select a couple of files. Oops, wrong button there. Let's go back to that. I'm going to select a couple of files, and we're going to now go and archive that data. So the archiving job here is we're actually taking a full copy of that data from the source, from primary storage, and we're going to move that data forensically sound into an archive on cloud-based storage. This could be either NFS exported storage, SITS exported storage, or cloud-based storage using an S3 interface, either on-prem or truly in the cloud. We can go again and look at the archiving job itself. We just ran this job. We've got 4 files. They've been archived. We actually do a validation to make sure, a validation check to make sure that they are actually in the archive. So every file that's put in the archive is validated. Now what we can do is once that's there, we can delete the data on primary storage, but we still have searchability of that data. So again, here I'm going to clear my search results. Now I have the ability from my settings panel to be able to search on just data that's been archived. So only data that we put in the archive on cloud storage. So I'm using the same search interface, being able to see that data, being able to look at that data from a full text point of view, look at the metadata, the security of those files. I have that all intact, located on my cloud-based storage, and I can produce those files at any point in time. Being able to, as we said, free up that primary storage to a much less expensive storage. Okay, I want to kind of change a little bit and move to protection and monitoring of the data in place. What we really want to do here is ensure that data can't be accessed by anyone without the proper authority. And ultimately, we want to make sure that the data hasn't been altered or corrupted or hidden by any internal or external bad actor. I'm going to go through 3 examples here. The first example I'm going to go through is finding data across the enterprise that is readable by everyone, that active group everyone. Not all data across your network. I don't believe that your data is going to be, you want to read to everyone to have access to that data. So we can actually search for that with the Index Engine's application. So I've got a saved query here. I'm going to go through my everyone query. I'm going to load that query up. You can see I'm looking for all data that's readable by everyone. I'm going to run that search. My results are going to come back. I can look at any one of these files now and look at the security ACLs of those files. Index Engines actually indexes the security ACLs, and I can see here that everyone has access to these files. So now I have the ability not only to look at it at the single file level, but now we can go and look at our reporting capabilities like we did before and start to drill down and see what type of files everyone has access to. What are the extensions of those files? Who owns that data? The owners of the data. And see if I did locations and the locations of where those files exist. So now I've got the proper set of reports and reporting capabilities to now go and start to take action on that data and secure that data in place. Our second example here, I want to look at files that are located within the finance group shares and look for data that's in that finance group share that are accessible by users that shouldn't have access to it, accessible by users that are not in the Finance Active Directory group. So we've actually run that search. We've tagged that data. I want to go look at that search on that tag. So we've already done that search. I've got files readable by users not in the finance group. I'm going to run that search. And I'm going to look at that data. I don't have locations, but I can look at the results of that data. That's where I want to go to. I want to look at the actual results. You can see here that we can look at any one file. And now I can look at, I see here that there's Mickey M. Mouse is not in the finance group and should not have access to that data. So I can, by indexing the ACLs and integrating with Active Directory, we can now start to search and identify users who shouldn't have data, who shouldn't have access to data in certain locations. So again, being able to look at it at a single file level, but also now being able to go back to my custom reports and being able to look at who owns that data, what type of data do people have access to, the extensions of those data, and so forth, just like we did before. Okay, the third example I want to do is, before we do this example, let you know that Index Engines has the capability to index the Windows file event log. By doing so, we'll now be able to actually search on and display files that have been accessed. We can do this either for all users or for a single user, find out what files they have accessed or what files have been accessed by all users. We can do this over a date range, a specific date range. So show me the files that have been accessed by a certain person in the last 2 days or in the last 60 days. And I can select different types of access. So I want to look at them whether they were read accesses, write accesses, browse accesses, or so forth. So go back here to my my search results. I'm going to clear up that search. I do have a search ready for this. So we have an operator called, it's our event log operator. I'm going to load that search into my search interface. You're going to see here that this event log, I'm actually searching for the user, for a specific user, and what files they've read or written within the system. I'm going to run that search, and again, I get my list of files that have been written or read by mmouse. Again, I can look at those files. Now I'll go over to my users and see that mmouse actually read that file and actually had many accesses to that file, both read and write accesses as well as others, on August 31st was the when they did that, after we indexed with the event log. So now again, I have that capability to now start to look at who's been accessing data, whether it's a single user or all users, over a date range with different access types. Okay, so I want to kind of wrap this up with one last thing and talk about monitoring and protecting data from bad actors. Index Engines, because we can index at the full content level, has the capability to detect changes in data on subsequent indexing runs. Changing data that may be indicative of bad actors like ransomware. We've added this feature to our next GA release. With this feature, we can automatically detect those changes in place. We can then generate a CSV file with various reportings, whether it's a report on entropy changes, entropy being encryption being a form of entropy, and encryption naturally is one of the big players within the ransomware arena. Be able to generate that CSV file showing trends over time, and being able to help a customer identify what may be happening within their data so they can take action, go look at that data, determine are these changes in fact indicative of a bad actor, or are they normal changes in their network. There's a lot of detail around this specific feature. We can have a much more in-depth discussion about the functionality, about the workflow. And if you're interested in this, please contact Index Engines, and we can set up a separate meeting to discuss our security analytics in this particular area.
With that, I'm going to turn it back to you, Michelle.
Great, thanks, Ed. And I think as we look at some of these last features, talking about managing data, talking about protecting data, it really all comes down to automation. And the GDPR requires monitoring and in compliance with the laws and managing the activities, training the staff, conducting audits, a lot of different steps on an ongoing basis. So from an Index Engine's perspective, all of the indexing that we've done can be automated. It can be run incrementally to keep the data set current. Any preservation or archiving that's been configured can be run in the same fashion. All of the queries and policies that you build throughout your use in the tool can be stored and also be automated so they can be run and kept up to date and current. All of the reporting with CSV or text file, all of our activity logs and audit trails are all going to be there to ensure that as we move forward, we can support the DPO doing their job, right? We can support that ongoing monitoring, that ongoing process. So as we wrap up a little bit, and we hopefully can get to a couple questions, the two things I want to talk about, one of them is rot. We talked in the beginning about, the step of identifying the rot, and we bring that up a couple of times, although it's not necessarily a mandatory part of GDPR or even traditional part of GDPR. It does fall through to the topic of minimization. If you don't need it, you shouldn't keep it. But not only does it reduce the scope of data that you're managing, it can reduce infrastructure and storage costs, not to mention risk. And we've seen numbers anywhere from 30 to 60% of data under management that ends up being deemed rot and deletable during these kinds of projects. Put that together with numbers from analysts saying that the TCO for primary storage can be from $1 to $5 million a petabyte. So why is this also important, and why is it part of a GDPR presentation? Well, what we've found is that despite the fact that GDPR compliance deadlines are coming quickly, many organizations still don't have budgets. It's simply not a line item in this year's funding, and it's really a hang-up in getting the process started. The ROI of simply cleaning up the mess in this process can create exactly what we need, which is funding to get these projects underway and get in a state of compliance. So look at that, the last slide. We're just about through today. From our perspective, if you've taken all the steps that we've talked about here, I'm pretty sure council will agree that you've made a good proactive effort to comply with the GDPR. You've probably also found some rot, eliminated it, reduced some storage operating costs, ongoing budget. You might have migrated data to more appropriate data stores and effectively implemented an entire IG strategy in the process. But the bottom line here is that index engines can meet the demands of the GDPR and deliver a cost-effective solution to do so.
Okay, thank you, Michelle. Thank you, Ed. Thank you for your time today. If you do have any questions, there's been a number of questions that have come through. You can always contact us at info@indexengines.com. We also have an Index Engines playbook on our support for GDPR compliance, which goes a little bit deeper into the presentation today. It's a good companion piece. We can also make the recording available. It should be available later today, as well as a slide deck. We've had a number of requests for that. A number of questions have come through during this session. One of the questions, maybe Michelle, you can help out with is, do you have advisory partners that can help with policy development around GDPR?
We absolutely do, and we find that it really goes hand in hand with the technology. It's not just a technology solution, so we can definitely get in touch with the people asking these questions and provide some options globally to do this.
Okay, another question, maybe Ed, you could answer here. They're asking, can this be installed? You're talking about large-scale environments. Can this be installed on a single server or a small environment and grow to other locations?
Absolutely. The Index Engines software application runs either on a virtual server or on a physical server. We've got many customers in it, that most of our customers for GDPR applications run in virtual environments, and the solution scales. So when you get into the petabyte class, you can actually install many instances of Index Engines across your environment, whether it be in one location or it can be federated across geographical locations to scale to that petabyte level.
Another question is, do you have representation in Europe? I can answer that one. Yes, we do. We have partners in Europe, as well as APJ, and we have our own office in Europe. If you're interested, you can reach out to us and we'll connect you with that team. A question for maybe Michelle, you can answer this. What is the largest environment that has been supported?
Both on the metadata and full content level, it's been way into the petabytes. Ed, what would you say?
We've done, installations for in the 20 to 30 petabyte environments as well. We recently did a metadata and a 2.5 petabyte. That installation was actually done. The indexing, the first pass indexing was done in about 3 weeks time frame with I think 6 servers. It was 6 virtual servers. Small footprint for a very large environment to get them searchability and ready for classification.
Thanks, Ed.
Okay, I'm being told we have to wrap up, so thank you all for your time today, and please reach out to us at info@indexengines. Ask for this guide. We're happy to send it to you, and hopefully we can speak to you in the future about your GDPR requirements. Thanks, everybody.
Thanks so much.
Thank you.